Yes, hello everyone. Today we are going to solve some numericals. So on the screen you can observe the ninth one, that is the second one. So a 240 volts DC series motor takes 40 ampere, runs at 1500 rpm, and the total resistance of 0.3 ohms. And the common that the value of additional resistance must be added to obtain the rated torque at 1000 rpm at starting. Okay, so in this numerical he given the total data. So again I'm repeating the problem. A 240 DC series motor takes 40 ampere, runs at 1500 rpm, and the total resistance of 0.3 ohms. Then the value of additional resistance must be added to obtain the rated torque. First one is the 1000 rpm, second one is the at starting. Okay, let's solve this problem. Let's solve this problem. Right. So first of all we need to write the given data. You need to write the given data. Okay, so what type of motor it is? Series motor, right? Series motor. So you need to write the series motor first. DC series motor. DC series motor. Now, so in this he given the voltage first. So the voltage V is equals to 240 volts. 240 volts. And remaining things also you need to note down. So the armature current, that is 40 ampere. 40 ampere. Next, the speed also is given, right? So the speed is 1500 rpm. 1500 rpm, and the total resistance is given. So the total resistance Ra plus Rsc here. Okay, in case of DC series motor, the total resistance can be considered Ra plus Rsc, that is given by 0.3 ohms. 0.3 ohms. And next, he given some condition. He given some conditions. At speed, N2 is equal to 1000 rpm. When speed decreases to 1000 rpm, what will be the additional resistance to be put into circuit? Okay, that is a question here. That is a question here, right? And apart from this, in case of DC series motor, you just draw the circuit first. You just draw the circuit. Okay, so give the brushes also here. Put the brushes, and this will be the field winding, right? DC series, right? So you need to give the supply. You need to give the supply. Okay, so this will be the field current. Okay, and this will be the series resistance, and this will be the armature resistance, and this will be the motor, DC series motor. Now in this case we can consider IA1 is equals to IA2. Okay, and that means I series current ISC1 ISC2. Okay, because the torque is constant. Torque is constant, as we know that the torque is constant, right? So the torque can be represented by pi sc into IA1 and pi sc 2 into IA2. Okay, this is the pi sc1, this is the pi sc2, right? So in case of series motor, the pi also can be considered as the armature current. So IA1 whole square is equals to IA2 whole square. Okay, that means in the bracket I am writing pi sc is equals to armature current IA. Okay guys, now IA1 is equals to IA2. So don't be confused with this. Now I'm going to derive the external resistance value, so that we don't have a direct formula for to find out that external resistance. We need to find from the back EMF only. So from this proportional constant, I am going to write N2 by N1 is equals EB2 by EB1 into pi 1 by pi 2. Okay, again you need to write that, evaluate that equation V minus IA2 into RA plus RSC plus R external, because this is the second back EMF. Okay, so now EB1 can be represented by IA1 into RA plus RSC, right, into pi 1 by pi 2. So what I said, the constants, right, flux is constant, so you can take directly into 1. You can take directly the value of pi 1 by pi 2 is equals to 1, right. So let's solve this. Now substitute the value of N2, 1000 by 1500, V is equals to 240, which is given in the data, and IA2, already you know that I1 is equal to I2, right, so you can substitute 40 directly, and total resistance means RA plus RSC, that represents 0.3. Now in the denominator you can write 240 minus 40 into 0.3. Okay, so just do the calculation for this. The two zeros will get cancelled here, and if you calculate this value, if you calculate the above simplification, you will get the value of 1.9. Just cross verify the value. Yes, exactly 1.9 you will get. Okay, now the second case is given at starting period how much resistance we need to be add into the circuit. So the condition is given starting. So at starting the rotor speed will become 0, and when the rotor speed is 0, the back EMF is also 0. Okay, so that the equation which we have from that external resistance V minus IA2 RA plus RSC plus R external RE. Now if you substitute the value of 0 and V nothing but 240, IA2 represents how much, 40, and the total resistance 0.3 plus R external. Okay, if you calculate this, you will get the value of Rex is equals to, okay, Rx 5.7 ohms, guys, 5.7 ohms. This is how we need to find out the R external value. Okay, so we need 5.7 ohms for initial condition. You need to add up 5.7 resistance into the circuit. Okay, and in the same manner we need to add 1.9 ohms when the speed decreases from 1500 rpm to 1000 rpm. Okay, I hope it is very clear. So two resistances we need to find out for the two different cases, right? Okay, I hope it is very clear. Thank you.